Hello everyone, in continuation with the previous part of the video, there we had discussed the first half of the module. Now we are going to discuss the second half of the module. Here we have some super important algorithms like S-find and candidate elimination algorithm, okay? And along with that, there are some theory questions as well. So totally how many questions are there in this? 6 important questions are there. So I'll be telling you what are those 6 important questions and how do you need to write in the exam, okay? So before starting, if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this, okay? So let's get started with the first important question, which is you need to know what is the difference between procedural language and declaration language. What do you understand by the term procedural? Procedural means the knowing of how to do things. Okay, how to do things is nothing but procedural knowledge. Declaration knowledge means explicitly telling some facts, right? That is an apple. That's an declaration knowledge. I know how to play cricket. That is a procedural knowledge. Okay, so that's the first difference you need to write. Knowledge of facts or concepts, that is declarative knowledge, and predictive knowledge is nothing but procedural knowledge is nothing but how to perform a specific task or how to operate. In the same way, you'll write the second one also, knowledge about something true or false. Okay, just true or false, that's the knowledge we are talking about in declarative, whereas in predictive you have to write knowledge about how to do something to reach a particular goal. It is explicit knowledge, it is knowing knowledge mean how to do things, that knowledge, okay. So what are the tasks we will be doing, that knowledge, okay, it is a task knowledge. Moving on to the second super important question, which is backward and forward reasoning. Okay, there are two types of reasoning: forward and backward reasoning. Forward reasoning means what? You will have initial state and you will be doing some procedures and you will be reaching a goal state. Backward reasoning means what? You are in a goal state and you want to know where you came from. That is the you will be reaching the initial point. These two reasonings are the backward and forward reasoning. So first thing you will be writing is the object of search procedure. To search something is nothing but to discover a path from the initial space to the goal state. That is nothing but the search procedure. So first thing you will be writing this, what is search procedure. Then you will be writing there are two ways to do that: forward reasoning and backward reasoning. In bracket you will write from start state to the goal state and from the goal state to the start state in the case of backward reasoning. After I've written this one, you need to deep dive into what is backward and forward. So it is called as backward chaining rule and this is called as forward chaining rule. For example, if some person has some disease, some the diagnosis will be there in his body, so by using the diagnosis he will reach what disease it is, right? That is called as backward chaining system, okay. We know what is the conditions and by using that we will be reaching the solution, okay. That is called as backward reasoning. Forward reasoning, instead of directed by goals, we sometimes want to go to the goal by incoming data. For example, you have the inputs and you'll be moving forward and you will be again getting some inputs. You'll be moving forward until you reach what? A goal state. So that is what is called forward reasoning. In that case, if we have a lighter here and the fire is on the lighter, if you touch the lighter you will be moving your hand away from the lighter, right? Why? Because when you keep coming close to the lighter, the temperature will increase in your hand, and by using that your brain will sense that temperature is increasing, don't move your hand towards that thing. So slowly you will move backwards. So you are reaching from the initial state, which is from the hot temperature, to the final state, which is the normal temperature, okay. That is what is called forward chaining rule system. These two things you have to write after that, okay. After that you can write some examples of typical forward chaining in case of the AI. So how will be AI looking in forward chaining is you have to give some rules here, okay. Then you will be giving some facts and you will be deriving some things. For example, if hot and smoky, then add fire. If there is hot and smoky, then add fire, means if it is hot and smoky somewhere, then it means that there is fire at that time. If alarm beeps, then add smoky, means if alarm is beeping, then understand that there is a smoke somewhere in the room. If fire is there, then switch on sprinkles, means if fire is there, obviously we want to switch off the fire, means extinguish the fire, so we'll switch on what? Sprinklers. Now we have this rule, the facts are given. Alarm beeps. If alarm is beeping, what does that mean? We have to add smoky. Now we have added smoky and alarm is beeping. Also it's given that it's hot, so alarm beep, by that I got smoky, and it's also given it's hot, so smoky and hot means add fire. So what conclusion we can reach is we'll get fire here. First we'll get smoky, then we'll get fire. If fire is there, what you have to do? Switch on sprinklers from the last one. If fire is there, switch on sprinklers. That's how forward chaining will work. Typical example of backward chaining also you have to give. Should I switch on the sprinklers? You will be asking this, should I switch on? Why should you switch on? Then you will go back if there is fire. Why there will be fire if it is smoky? Why there is smoky if it is hot and smoky is there, then fire will be there. Like that you will be keep on going from the goal state. See, observe carefully. You are going from the goal state till what? The initial state. This is what is called the typical example of backward chaining. Now, sometimes we need to combine both. That is called as combining forward and backward reasoning. Sometimes we will use forward reasoning. Sometimes we will use backward reasoning. That is what is called the combination of forward and backward reasoning. Some problems we will solve in a better way in that only. So basically, we have to give the definition. Then you will have to give example, the type of it, and the typical chaining example in the AI how you will be using. Also, then finally you will be writing about combining forward and backward reasoning. So that was about the first question. Moving on to the next super important question, which is explain logic programming. Very, very important question from exam point of view. Logic programming means what? You will be programming the system to do some tasks based on some rules, and the derivations of that rules, it will do some task. Okay, there will be some rules, you'll be deriving some formulas, and by using that formulas you'll be solving some question. That program is called as logic programming. So first point, what you will write: logic programming is a programming language paradigm which logical assertions are created in a program, okay, or viewed in the program. So it is just a language. For that we'll be using Prolang. So what does Prolang do is it will create a language here which will be having rules and different codes here. By using those codes we'll be deriving some results, okay, we'll be reaching some conclusions. That is what is called logic programming. There are several logic programming. The most one which we will be using is Prolog. That's the second point. You'll write first, write the definition, then write which programming language we'll be using. Then what is Prolog? Prolog is a program described as a series of logical assertions. That's the third point. Each of which is a horn clause. Horn clause I discussed in the earlier videos, I guess in the module 2 only, like the part 1. So a horn clause is nothing but it has at most one positive literal, and P and comma not P is written as like this: P goes to Q. Okay, so basically you can watch the part 1. There I have explained the horn clauses to get more information. Okay, so what is having horn clauses? That will be using in the prologue. Okay, only prologue will be using horn clauses. So this is also the basic examples of what is prologue. In prologue we'll not be using and or. Instead we'll be using comma and dot. Okay, dot is for and operation, comma is for or operation. Okay. In logical implications, P implies Q. How we'll write? P goes to Q, right? In the same, we'll be writing it as backward in prologue, like Q, then minus P. Minus P is nothing but negative of P, means not P. So some examples are given here. This is in the normal form, and here it's in the prologue form. So this is one of the things you need to write to give the examiner means you need to show to the examiner you know the basic syntax and how it works, what are the conversions happening. So you need to give one example, at least give one example. Okay, so I'll be explaining what it is. For all x, okay, for all x, pet x and small x implies apartment pet of x. If pet x is there and small x is there, what does that imply? Apartment pet of x. So let me take as PSA. Okay, P and S goes to A. Now if I convert this into the by using the formula like A goes to B, it can be written as not A or B, right? Not A or B. In the same way, if I do for this one also, what I will be getting is not of P and S and or A. Okay, not of P and S, or what is not of P and S? Not P or not S or A. This is the final thing I need to get, right? That's what we'll be writing here. See, pet comma small x. Comma will be using for AND operation. Okay, comma is used for what? AND operation. Now as you can see here, I have written this one and I have written apartment pet here, and this symbol is there. What does this mean? If I take this as A and this as implies, and I will be writing here in prologue, as I already told you how we will be writing is, if I want to write P goes to Q, I will be writing in this form: Q, then colon, then P. Like this I'll be writing in backward form. This is nothing but this symbol. Okay, so in backward form we're writing QP. So P implies Q was there, so I'll be writing Q then P. Okay, and then it will be connected by a dot because the next rule also applies. So these three rules are connected by AND operator, right? So this rule and this rule and this rule. So you only tell me what will be for this rule. For this rule, it is in the same form again. P goes to Q. So I'll be writing pet of x. Then I'll be writing the symbol, and then I'll be writing cat of x or dog of x. Or I'll be not writing because there is no symbol for or actually. Comma is for and for or there is nothing. Okay, you just have to leave an empty space. So the answer will be like this: pet x, cat x, dog x. Right. So pet x, cat x, dog x. You can separate that also. Okay. So that's what it is given here, and third one also goes in the same way. So I hope you got a brief overview of how it works, and that's what you need to write in the means the next point. Okay, after that there are some matching rules. That's the next point you need to write. There are two matching rules you'll be using indexing, or you'll be using via matching variables. So for that there is an algorithm, and that's all you have to write in the logic programming. So matching means what is there, you need to search that, and you need to fetch what is with that accordingly. Okay, that is called as matching, right? Indexing means what? One way is to select the applicable rules, to apply a simple search through all the rules, search all the rules which match takes that, search all the rules which match takes that. That's the thing you need to write in indexing. And matching with variables, variable means there are many rules, so how to match many rules is whichever rule matches you will be executing that and selecting that. Fine, three rules you have to three things you have to remember: match, select, execute. That's what you'll be writing in the RETE matching algorithm. It consists of three parts: rules and protections, working memory, and inference engine. Okay, rules and protection define what can be applied. Working memory describes what has happened before, what were the results we got, and by using that results we'll be calculating the further results as well. Inference engine does the calculation part. Okay, so there will be three things happening: match, select, and execute. Do some things, procedures, whatever matches, select that and execute. That's all what is there here: match, select, and execute. This diagram is compulsory for you to make, and this also you can make by using the architecture. What it is: input is coming, user interface is there. There will be inference engine which will be using some rules in the working memory and the knowledge base. By using that it will get the output and it will show to the user. So this is the architecture and this is the inner working. After I've written that one, you can write few words about RT algorithm. For example, I will tell you some important things. The above cycle is repeated infinitely, so only we will be using RET algorithm, because if one rule is matching, we'll be using that and doing it again matching, again doing it again. It will keep on going forever, right? So RET algorithm will do what? It will match the most specific and best optimal rule, and then it will apply and it will just exit. Okay, so RET algorithm is many match algorithm. Many rules will be matching, will be just applying those rules which are compulsory. It uses the forward chaining system, which generally employs sophisticated conflict resolution. So it just uses forward chaining, and it gains the efficiency from three major sources. The first one is the network of rule condition. Second is like structural similarity, where we'll be having a structure and the rules will be given there. And persistence of variable binding consistency is there. Okay, means the previous rules will be applied. Based on that, we'll be applying the new rules here. Here comes the most important part of the second module, second part, which is concept learning. Okay, so in this you will be having two algorithms which are super important. Okay, so make sure you listen it very carefully, because it is a bit complicated. Okay, but I'll be trying my best to explain you the concepts. Okay, so let's get started. So in concept learning, what is the main thing is there will be some boolean valid function given. Okay, function means some statement will be given, like I like apple. Okay, so for that, I like apple, I like mango, I like orange, all these things there will be yes or no, means whether the statement is true or not, that will be given to us. So what we have to do is, whichever the statement is given like yes, yes, in that I'll see what are the similarities. In this I can find out the similarity, like for example, I like mango, I like orange, and I like apple, I like strawberry. So the similarities what I can find is mango and orange both are what? Orange color. So orange color fruits I like, red and strawberry, apple and strawberry are red, so I don't like that. So that is the conclusion I can form. So if another fruit is given in the orange color, so I'll be telling that most probably I'll be liking it based on the previous data. That's what we'll be learning here and deriving. Okay, so that's what it is called concept learning. So there's a famous example here about enjoy sport. Okay, enjoy sport means what? Days on which John enjoys his favorite water sport. This is the statement is given to us. Okay, so for this some data is given. So John is enjoying the water sport on this day, and this day. In this day, John is not enjoying water sport. Okay, so given a day and these parameters, some things will be given, so we have to find out whether the John will be enjoying that day or not based on the previous data. So that's what we'll be learning here. Before moving on to the example, you need to know some basic points. Okay, so for each attribute, the hypothesis will either indicate a question mark or a single required value or a null value. Okay, so let me explain you what are these terms mean. What is attribute? Attribute is nothing but sky, air temperature, humidity, wind, water, and forecast. Those are the attributes. Okay, And what is hypothesis? Hypothesis means what? For example, if I tell you, if the sky is sunny, if the sky is sunny, you tell me whether John will like the sport or not. So what you will be doing, you will be seeing the previous instances when it was sunny, did he like or not, whether it was sunny he liked or not, whether it was not sunny he liked or not, whether it was sunny he liked or not. So based on all the previous data, you come to a conclusion that when it's sunny, most probably John is going to like the water sport. If it is not sunny, he most probably is not going to like the sport. This is the conclusion we arrive at, right? So how did we arrive at that conclusion? By using the hypothesis that sunny. So that one word sunny is nothing but the hypothesis. Hypothesis means my thinking, what I think is the most correct solution. That is what is called hypothesis. For in this case, the hypothesis is that if it is sunny, he will like the sport. Okay, if I get some more data like sunny is given and no is there, then at that time the hypothesis will be destroyed. Okay, it will not be valid anymore, because for one instance it is no for sunny. But until I get this instance, I can tell that the hypothesis is true, that whenever it is sunny, he will like the sport. Okay, that is what is called hypothesis. Question mark means what? Any acceptable value. For example, if I tell you that John will like the sport when it is sunny only, or if it is rainy also. For example, if I get another instance here, rainy is given and it is given yes. Okay, so in this case what I will do, first I will start from here. Sunny is there, so what is the question? The question is, John will like the sport only if it is sunny, or if it is rainy also he will like. So what I will do, sunny yes, rainy no. Till this point what I have reached the conclusion, if it is sunny yes, if it is rainy no. Here also it's the same thing. Sunny yes means if it is sunny it is yes, if it is rainy it is no. So I have a specific word, like if it is sunny he will like the sport. Now when I reach this conclusion, it's given like rainy yes, so my whole hypothesis got destroyed. So I cannot explicitly tell that if it is sunny only he will like, because rainy is also there where he has liked, rainy is also there where he has liked. So in that case I'll be putting a question mark, because I don't know. Whenever you don't know, if there are two or more instances where you have yes for the same attribute, at that time you will tell that question mark. Question mark means in sunny also he will like, in rainy also he will like, if it is something else also he might like, right? Until we reach that conclusion, we cannot write question mark. If we reach two or more instances which has yes, then we will say it as question mark. That is called the question mark. Okay, then what is a single required value? Single required value means sunny. Okay, just consider this example: sunny, sunny and sunny. For rainy it is no, for sunny it is yes. So my single valued attribute will be sunny. That's my hypothesis. Okay, that's all. And what is null? Null is nothing but no. Okay, means for example here for sunny also it is no, and here also it is no, here also it is no. For none of the values he is enjoying sport, then what is my hypothesis? Null. Because null values he is enjoying the sport, no values he is enjoying the sport. No matter what it is, whether it is sunny or rainy, John is not enjoying the sport. Whether it comes to be cloudy here in the next instance, and it is yes, at that time what change I will make? I'll make this as cloudy, because cloudy I got yes, so the answer is cloudy. If I get another instance like thunder, and I'll get yes, at that time I will cut this and write question mark, because for cloudy and thunder both I got yes. I cannot specify a single instance, so for that question mark will be taking place here. Okay, so I hope so you got the differences between question mark when we'll be using single required value and when we'll be using null value. Okay, and what is hypothesis? I told you, right? Whether I am getting some attribute for which I'll get all yes values, that is called as hypothesis. Then I can include, if it is sunny, most probably John will be liking the sport. That is my hypothesis. So hypothesis of x. X means what value I'm putting. Like for example, sunny. Hypothesis of sunny is equal to 1 if it is yes at the end, 0 if it is no at the end. Okay, so whenever it is hypothesis of rainy is no, then it is 0. Hypothesis of sunny is yes, so it is 1. Okay, so that's how we'll be representing in the mathematical form and the function form. Okay, hypothesis that a person enjoys his favorite sport on cold days with high humidity is represented by the expression. Now see, I just told you about one attribute, but it's not about one attribute, there are many other attributes, so we have to consider all this. Sunny warm, he's enjoying sport, yes. Sunny warm, enjoying sport, yes. Rainy cold, no. Sunny warm, yes. So I can specify it further, like not just Sunny now, but even I can specify Sunny along with that warm should be there. If it is cold, he will not enjoy the sport, right? Sunny along with that warm should be there, then only he will enjoy the sport. So some more specific answer I'm getting, right? I have included two more attributes. So yeah, that how I will represent is how many attributes I have. First, I will make that many spaces. I have 6 attributes, so I'll make 6 spaces here. After making 6 spaces, I'll be representing by question mark where I don't have the correct value. I'll be representing by the specific value where I have like yes for that, and here also if it is yes, I'll be expressing that, and wherever I don't have, I have multiple values, I'll be representing by question mark. If I have all no answers, I'll be representing by null. So what does this mean? Cold, high, why I have written question marks here? Let me explain you. Hypothesis that a person, what is the hypothesis? Read carefully. Enjoys his favorite sport means at last yes should be there only on cold days. So cold days should be there and high humidity should be there. Cold days and high humidity should be there. Okay, so what will my hypothesis become? I'll be expressing I have not given this information, so question mark, it can be anything, but this should must be cold only because I have been given cold and high humidity, right? Cold and high. Wind can be anything, water can be anything, forecast can be anything. So question mark, question mark, question mark. So whenever I have cold as well as high, at that time if I get yes, at that time this hypothesis is true, else hypothesis is not true. In this case, hypothesis is obviously not true because here I've got no, right? But this is how you represent hypothesis. That's the point of the means concept which I'm explaining. How you will write hypothesis, that's the point I'm explaining here. I'm not talking about yes or no at the end. Okay, this is how you'll write hypothesis. If they give you about, for example, strong and warm water, what is the hypothesis? You'll just write question mark, question mark, question mark, and you'll be writing strong here and you'll be writing warm here, and then again question mark. That will be your hypothesis. Okay, this is how you will be writing hypothesis. The general hypothesis that every day is positive example is represented by this one, question marks. Okay, for example, if I have all yes here, okay, if I have all yes here and there are differing values, for example, none of the column has all the same values. Okay, like sunny, sunny, rainy and sunny, this I got question mark. Warm, warm, cold, warm, question mark, because cold and warm both have yes at the end, right? I told you all the things are yes here. So any of these things, if you have multiple values, you have to put question mark. Here it is strong, 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 so I can write it strong, but let's see, let's suppose that it was weak here. Okay, so here also question mark I'll get, here also question mark I'll get, here also question mark I'll get. So this is what positive example. No matter what the day is, what the air temperature, no, or what the humidity, wind, it doesn't matter to John. He will enjoy the sport. Based on how much data is given to us, we can conclude that because many different values are there in each row. For all, that John has enjoyed the sport. So all the days are what positive examples. All the days are what positive example means. All are yes. Okay, so that's what I'll represent question mark. It can have any values in the columns. It doesn't matter to John. He'll enjoy the sport. The most specific value hypothesis is that no day is a positive example. No day is a positive example means no matter what the day is given here, how many values are given here, it doesn't matter at last if at the end all are no's. At that time, what is the conclusion is it is null, means no matter what attribute it is, he is not enjoying the sport. So at that time all the values will be null because none of the values I can specify here that he will be enjoying sport, because at the end it is written no. So whatever the values are here, for all I should take null, because by using this only he's able to not enjoy the sport. Okay, null values have to write. So that's what it is about the most general. He'll consider all the days. It is more specific, he'll consider none of the days. Then what is x? X is the set of instances. Set of instances means how many possible days are there, each instance. Okay, for example, one of the instances can be sunny, warm, high, strong, and warm, and sure. This is one instance. Like that I can replace this with cold. I can replace this with weak. Like that, how many instances can happen? That is called as instances. Okay, x is the set of all those instances. Okay. X is the set of all possible days, each represented by the attributes chi, air temperature, wind, water, and forecast. Okay. So x can be having either 0 or 1. At the end, it is defined whether it will be true or false. That is known as target concept. Target concept means at the end for one x, is it yes? If it is yes, it is 1. If it is no, it is 0. The target concept corresponds to the value of the attribute enjoy sport. C of x, the target value is 1, then it means he is enjoying the sport. If it is 0, means he is not enjoying the sport. Okay. So C of x is 1, C of x is 0 for positive and negative example respectively. And the ordered pair x comma C of x. For x value, if C of x is 1, it is called true. If it is not, then it is called false. Okay. So what is D? D is the set of available training examples, mean whatever the data is given to us. X is the set of all values. Okay, X is a set of what? All values. And D is nothing but just what we have been given with, that is D. H is the set of all possible hypotheses. For example, what the hypothesis could be, I can take just one hypothesis, like all question marks. If I take all question marks, any value it will be there, that can be acceptable. That is what all question marks. If I just specify all question marks except the second one, here I'll write cold. So my hypothesis is just that here it should be cold, and rest of the things anything can be there. Okay, that is my hypothesis. In this case, I'm getting yes. Okay, for example, if there is a data set in which I have yes for cold, and here I have all no. Okay, no, no, no. Just for cold it is yes. So what hypothesis I will form? None of this is same here. Okay, assume that none of this is same here. Just that wherever it is cold, I got yes. So my hypothesis will be that whenever air temperature is cold, John is liking the sport. That is my hypothesis. No matter, I don't care about this. I'm just telling that whenever the temperature is cold, John is logging the spot. That is my hypothesis. Hypothesis means my thinking or my predictive value. Like if it is cold, he will mostly like the sport. That sentence is called hypothesis. Okay, so H is the set of all possible hypotheses. For example, I can take here first value I can ignore and take second as warm, and third I can take as air temperature as something, humidity as something. All that possible combinations, how many changes I can make, that is called as set of hypothesis. Okay, and hypothesis also value can be 0 and 1 based on what at the end value I get. If it is yes or no, if it is yes it's 1, else it is no. Okay, so that's what the basic concepts are. The goal of the learning is to find the hypothesis such that h of x equal to c of x for all x in the capital X. Means hypothesis also should be true, and target value should also be true. If I tell that my hypothesis is that if it is sunny, the John will like the sport. Based on the 4 values rows I have given, I found that it is true. Like whenever it is sunny, it is giving me yes. So it is giving a yes at the end. C of x will be 1. It is sunny, then it is giving 1 yes. That means h of x is also true. Both are true. If I give an example, this example I'll consider, and I'll be explaining you how to approach using the candidate elimination and find S as well. Okay, find S is far more simpler than candidate elimination, but still let me give you an idea, and I'll be solving an example. So I hope so that things will be clear after that. Okay, first we'll be solving what? Find S algorithm. Okay, so find S algorithm has some basic key concepts which you need to know very well. Searching through a large space, there is a large space you're searching through, it is called as what? Hypothesis representation and concept learning as search. Okay, example, sky has 3 values. What are the 3 values the sky has? Sunny, warm and cloudy. For example, just assume it's not given here, but sunny, rainy and cloudy is given. Okay, it's not because it's just 4 values here, but actually sky has 3 attributes. Okay, so those 3 attributes are there. Along with that, how many attributes? Air temperature, humidity, wind, water and forecast has 2 values. Okay, maximum 2 to 2 values are there. Here 3 values are there. How many possible combinations can be there? For example, sunny with warm, sunny with cold, and rainy with warm, rainy with cold, coldy with warm or coldy with cold. Okay, sorry, cloudy with warm and cloudy with cold. Right, so how many were there? 6 were there. Right, like that, if I consider this also, for all those 6 I'll have 1 for this one into 2, all 6 for normal, all 6 for high, and that one set all with strong, all with some other value. Okay, weak, and all of that with a warm, and all of that with cool. So what's happening here? 3 values multiplied by 2 values multiplied by 2 values multiplied by 2 multiplied by 2 multiplied by 2. Right, if you didn't get, listen once again. I have sunny here, I have rainy here, example cloudy is also here. Okay, how many values I have? 3 here. Here how many values I have? Warm and cold, just 2 values. Okay, so how many to be total possible combination? Like sunny warm, sunny cold, rainy warm, rainy cold, cold cloudy warm and cloudy cold. So 3 into 2 happened. Now 3 into 2 6. I have 6 rows I have got. For all those 6 rows I can take with normal. I can take all the 6 rows with high. Right, 2 possible combination of this. So 6 into 2. Again, all that set which I got, that can be taken with strong, and that can be taken with weak. Again into 2. Like that it will keep on going until all the attributes are over. Remember, this is not the attribute. This is just the answer. Attributes are till here only, till the second last row column. Okay, so how many values will be there? 96 values will be there. 3 into 2 into 2 into 2. For all the rest 5 attributes it's 2, so it will be 96 instances. I can form 96 combinations of answers. Okay, so syntactically distinct hypothesis is nothing but what is the values I can take. For example, here I can take sunny and cloudy and rainy. 3 attributes I can take. If I add 5 and if I add question mark, at that time 3 plus 2, this also I can take, this also I can take. Right, 3 4 5 5 will be there, and for the rest also it will be 2 plus 2, here also 2 plus 2, 2 plus 2 and all. So 5 into 4 into 4 into 4 into 4 and so on, it will be 5120 total number of syntactically distinct hypotheses. If it is about the semantically distinct, you just have to take 5 common. If you take 5 common, take that as common and remove 5 from each of these. So it will be what, 4 into 3 into 3 into 3 into 3 plus 1 is for 5 taking as common, it will be 973. Okay, so these were some of the basic concepts. Now we can move on to the find S algorithm. I'll come to the algorithm after explaining the example. That will be more simpler. Okay, so see, this is the data set given to us, right? And we have to do the same thing. Wherever it is yes, what you will do, you'll mark as tick here. Okay, wherever it is yes, first thing what you will do, you'll mark it as tick here. Okay, after you have done that, you have to write here h naught. H naught is hypothesis 0. How many hypotheses will be there? Totally 4 hypotheses will be there. For each of these, you'll be updating hypothesis, and your final answer will be h4. What will be your final answer? Your final answer will be what? h4. Okay, so h naught means what? Initially you don't know about anything. H naught means you don't know about anything. Okay, so you'll be taking it as all null. Okay, you'll be taking it as all null. Second thing what you're supposed to do is, in h1 you'll be getting some values here, right? So these values you'll be writing it as such. Okay, so when you write those values as such, what you'll be writing is, instead of null values, you'll be just updating them by these values. Okay, that's all what you'll be doing in h1, and after that you will be moving on to h2. We will be only considering those values where we have yes here. Since the first one was yes, so I consider this row. If it was no here, for example, then I would have directly gone to what, step 2. Okay, so here what I have to do is, I have to just check two things here. Since second is also yes, what I'll be doing is, sunny is here, don't do anything. Warm is here, don't do anything. Wherever change is there, just mark it. Wherever change is not there, don't do anything. Don't do anything. See here, I got this change. Wherever you get change, mark it as what, question mark. Wherever you get change, mark it as question mark, because for both the yes values I'm getting two different values here. So that means that I cannot specify whether if it is normal he will enjoy, if it is high he will enjoy. Both of these he is getting enjoyment, so I cannot specify it, so I'll write it as generally question mark. Okay, means it can be either normal or high, that's specified by question mark. So what will be my h2? My h2 will be sunny, warm and question mark, because normal and humidity was there, again strong and whatever it was before. Okay, next is no. So whenever it is no, just write h3 is equal to h2, just write the previous thing. And for h4 what you will be doing is, again consider sunny is here in the previous. Okay, how you have to consider is, you have to consider these two, h3 what you h2 what you had written, and that you should compare with the next row. Okay, now we'll be comparing h2 with what, the fourth row. We'll be comparing h2 with what, the fourth row. When you will compare these two, what you'll be getting is, sunny is written here and sunny is written here. Okay, that's the same thing, so I'll not do anything. Warm, high is there and question mark is there. So when you get some value with question mark, what you're supposed to do, you should write just question mark here. Okay, that's all. Strong, don't do anything. Cool and warm, again a difference, right, question mark. Change and same, again a question difference, right, question mark. That's all. And sunny, warm will remain same. Now the rows are over, that's your final hypothesis. Okay, this is how you will be approaching this question. Okay, so that's the most generalized hypothesis. So that's what about the find S algorithm. If you get the basic idea of the find S algorithm, you can move ahead with the candidate elimination algorithm as well. In this we'll be using version spaces. So let me give you a brief overview of what is version spaces. Subset of hypothesis H. Okay, subset of what, hypothesis H. H will have all training examples. Subset of that is nothing but consistent with the training example. Subset of that, if we take some values here, like some hypothesis which I'm getting as yes, if that is consistent with what, D, which is given the training examples, the training examples are fitting with this one, then I am getting some version space. Means by this I have to use the answers. Okay, for example, this will be represented as VS. VS means version space. H is hypothesis, D is training example. And for all hypotheses in the whole set, means in the hypothesis whole set, there are many hypotheses, right? Each hypothesis will be considering, and we'll be checking if it is consistent with the given D training example or not. Means this hypothesis should be consistent with all the training examples. This hypothesis should be consistent with all the training examples. That all which are consistent, that will be taking and writing it as version space. Okay, that's what the version spaces. For example, if it is given here like question mark and x, y, and question mark x, question mark. So obviously if this is true, obviously this also will be true. Why? Because x and y wherever it is there I got yes, and I'm just specifying that if it is x obviously I'll get as yes. With y only I got, why not I'll get with x only, right? X and y both I got, why not if it is just x I'll get here. This question mark can be replaced with y, simple. So this is what my version space is, okay, are valid for all rows of the table, hence called version space. The hypothesis valid for all the rows of the table is called version spaces, okay. So here, so one algorithm is there. I'll come back to this after I have covered the example. Okay, so by understanding the example, you will get to know what you have to do here. Okay, so listen carefully. It's not that easy as the previous one. So I think you have to again rewind and watch this again. So in first trail only, listen carefully. I'll be explaining very slowly. Okay, so listen very carefully. See here, for positive samples, move from specific to general. I don't know how you I'll remember this one, but you have to remember this one. Anyways, I how I have remembered is, see, positive samples for this you take as luxuries. Okay, positive is nothing but luxuries. Okay, luxuries, and negative samples means what? Failures. In life we'll get sometimes luxuries, sometimes we'll get failures, right? So at that time, what is human nature? Specific to general. If you have got luxuries in your life, what you'll be doing is, specifically you will be doing some hard work on something because of which you got the reward luxuries. But what you'll be doing is, you'll be going to general. You'll be whenever you get some luxury in life, you'll get into comfort zone trap, and you will stop doing that hard work. Means you are again moving on to the normal life. Without doing hard work, you're trying to get luxury. That is what is happening from specific to general you are going. Whereas in the other case, negative samples, when you get failure in your life, you'll be living a normal general life, but then you'll be moving on to something specific. If you are getting more fat, what you will do? You'll move to the specific foods and you will eat that. When you are getting some backlogs, you'll move to the specific subject and focus more. When you're getting more marks in some subject, you'll start focusing less on that. You'll move to the general normal life, right? That's what I'm trying to say here. Positive samples, luxuries, move to from specific to general. If it is negative, move from general to specific. Just imagine, if you see here positive and negative, just imagine if something nice gift you got, what you will do? You'll obviously become lenient, and you'll get tap in comfort zone, which is general. If you get some punishment, you'll obviously go to some specific thing and focus more on that. That is nothing but general to specific. Okay, now how is specific represented? Specific is represented by this null values. Okay, null values is nothing but specific. Okay, and when it is specific, at that time, if you get as positive, you'll be moving from specific to general. If you are in already in general and you got a negative value, then you'll be moving from the general, which is question mark, to something specific, like for example dieting, right? So that's how we'll be using these two concepts. When you'll see the example, then you'll get a clear idea of what it is. Okay, for example, if each example is positive, make specific to general. If it is negative, then make general to specific. Okay, so now let's move on to the program, the example. In this example, the same example is considered, which one? Enjoy sport. The first thing what you'll be writing is s naught and what? G naught. S naught you will be filling with null values, as you can see here. G naught you will be filling with question marks. Okay, and data set is also given to us, the same thing which was given earlier. Whenever you are given with this one, you have to tell which is a target concept. Target concept is this one, right, where you have yes and no values. For yes you will write plus plus, and for no you will write as minus. Okay, that's what you'll be writing here. And after that, there are some things what you have to do is, first you have to consider which value it is. If it is positive, where you have to go? Positive means what? Luxury. If you get luxury, you will get trap in which zone? Comfort zone, right? So you'll move from specific to general, right? If you get positive here, means specific to general. So you have to consider specific here and move to the general. What do I mean by considering specific and moving to the general? Specific, if you consider, what you will be having is the null values here. 6 null values will be there, isn't it? And you are moving to the general. Moving to the general means you'll be taking one specific value and substituting the first row whatever is given. Instead of these very specific values, you'll be generalizing it. For example, here it was nothing was there, you are generalizing it to sunny, and this one to warm, this one to normal, this one to strong, this one to warm, and this one to same. Okay, so these things you are specifying here, and general you'll not be touching. Okay, whenever you get positive, what does that mean? You have to go from specific to general. So just you have to make the changes in specific. General don't touch only. Same goes true for the other one as well. In that, if you get as negative, you are moving from general to specific. Just change general, don't touch what? Specific. Okay, so let's move on to the next one, which is again yes here. Yes means what? Specific to general you have to move. Now again you will do the same thing here. Specific to general means you will have the specific values here: sunny, warm, normal, strong, warm, and same, the previous values which you have got. Now you have to generalize it. Means you'll be seeing the data set previously and you'll be making the changes. Now see here, this is the second row: sunny, sunny, you will not make any change; warm, warm, you will not make any change; high and normal you will write as question mark; strong and strong, no change; warm and warm, no change; and same, no change. So you'll be just writing a question mark in middle. Okay, that's all what the change you have to make. And general, what? Don't touch general because you have got positive. Then you will be going to the next one, which we have negative here. If negative is there, what you have to do? You have got some punishment. You have to strictly follow your diet. You are going from general to specific. Okay, going from general to specific. Don't touch specific, just change general. Don't touch specific, just change general. General, initially what you have, all question marks are there, isn't it? All question marks are there, so you have to change it to specific. How do you change all question mark to specific? See here, if you consider this one in general, I have written three things here: this one, and this one. Why I have written three things here? What are those three things? Sunny, warm, and same. Okay, sunny, warm, and same. Listen carefully. All the people get doubt in this one only, and rest of things also what they will not understand. So listen very carefully and remember what I'm doing. Watch 3 or 4 times, watch 10 times, but understand this step very carefully. If you have doubt, ping me on Instagram. I'll explain you personally only. Okay. So observe carefully. What I've written in general is all I had first question mark. Just 6 question marks I had in general, right? See here, in the first when I had started, I have taken all 6 question marks. But then sunny, warm, and the last value same I have taken as separate things. In S3 specific, I'm just writing 6 values here. But here I'm writing 6 values, again 6 values, again what? 6 values. Why I have written that? Let's see what is in the third row. In third row, I have rainy here. Okay, it is differing from the previous one. Observe this point. I have rainy here. It is what? Differing from the previous one. Temperature I have cold. It is differing from the previous one. Humidity I have, but it is not differing from the previous one. This is also not differing from the previous one. This is also not differing from the previous one. This is differing from the previous one. Which is differing from the previous one? If it is doesn't making sense, just by heart it. Just tell me what is differing. Whenever you have to go from general to specific, if you got a negative value, you are going from general to specific, the first thing what you have to see is what is changing. From the previous row when you are coming here, what is changing? Just tell me that. This row is changing, this row is changing, and this row is changing. Whenever there is a change, at that time you have to consider it and write a separate row. Consider it, write a separate row. Consider it and consider this and write a separate row. How many changes will be there? That many rows you will be writing in general. How many changes are there? That many rows you will be writing. How many changes are there? Rainy, cold, and change. So 3 rows you will be writing here. And in 3 rows, only one change you will be writing at a time. That's why we took 3 rows. Otherwise, I would have taken one row and write all these things, 3 things in one row. That's not the rule. If how many changes are there, make 3 changes, and one change just reflect in one row, second change reflect in second row, third change reflect in third row. Now tell me what the changes happened. The changes happened is that it is coming as rainy. Before what it was? Sunny, right? So just write sunny here. Observe this step carefully. Whenever change happens, just what was previous, that write that one, sunny. Rest you write question marks, question mark, question mark, question mark, and so on till the end. Next, this row is for what? This row is for cold. What was previously? Write that warm and write rest of the things question mark. First is question mark, then warm, all question marks. Third change is what? At the last I have change here. So last I will be writing change here, rest I will be writing question marks. Understood? If you get very simple, if you get no, you have to see which change is happening. Whenever you get no, just mark it as like this. Okay, just select this row, then see previous row wherever change is happening. Don't do anything, just mark it as a tick. We'll come back to this later. Mark this as a tick, we'll come back to this later. No change, don't do anything. No change, don't do anything. No change, don't do anything. Whenever there is a change, mark it as tick. After you have marked as tick, tell me how many ticks are there. 3 ticks are there. Write 3 rows here, empty rows, just write like this. Okay, after I've written that one, tell me if the change has happened, what was previous value? Write it here. rest of question mark. If it was this value here, what was previous value? Write that here, rest question mark. If it is change here, what was the previous value? Write that and question mark, rest one. Okay, that's how you'll be filling the G3 value. I had got sunny, I'll write sunny question marks. I had got warm, warm question marks. I had got same, then question marks. This is what you'll be writing G3. Got it? And S3 will not make any change. Okay, it will be same as the previous one. Same as previous one. Fine. So let's move on to the next one, which is again I got as yes. Yes means very simple. You just have to see the previous row value and this one value. So okay, S3 is here, right? Okay, fine. So I hope so I'll not be able to make this in one screen. So if you can write this somewhere, it will be helpful for you. Okay, so S3 what I've got, sunny is here and sunny is here. Okay, so will not make any change. Warm is here, not make any change. High is there, question mark, it will remain question mark. Strong is there, will not make any change. Cool is there, warm is there, you will write question mark. Change is there and same is there, you will again write question mark. So two question mark you will be writing here, here and here. At the last two you will be writing question marks. Okay, understood. Last two you will be writing question mark. Just write the last row here and write S3 here and compare it yourself. Same thing, very simple, and you'll not be making change to G3. But you can see here that there is something gone from here. You can see what? There is something gone from here. Now you might ask me, like you told that we should not make any change, but when I'm seeing here, I've means skipped this part, right? Last thing I have just deleted it. Why did I delete it? That's the question, right? So one thing you remember, before only if we tell all the rules, it will become very complicated. That's why we tell some rules, then we'll hide some rules, and when an exception happens, then we'll reveal that rule. In that way you'll be able to effectively remember all the rules. Okay, so that's one thing you have to forgive me about. Okay, so see here, one rule I'm adding: whenever you do something change to specific, okay, listen carefully. Whenever you make some change to specific, that means whenever you have yes value and you make change to specific, when specific changes, general gets jealous. When specific changes, general gets what? Jealous. When general gets jealous, it want to change also. Okay, but when general changes, specific will not get jealous. Specific will remain same no matter what general will do. It doesn't care about general. But when specific changes, at that time general should also change. Okay, it's like siblings. If one of the siblings does something, the other sibling gets jealous, the other sibling has to do. But when the younger sibling does something, older sibling does not have the option to do the same thing, right? So that's the same thing happening here. Specific is the older sibling, general is the smaller sibling. Fine. So what change has happened is just same has gone. Why same has gone? One simple answer. In the previous specific you observe, I had same here, but here I have written as question mark. But this one, warm and sunny, this remains same. Sunny and warm, this remains same. So I have not made any change for this one in general. Just that same was here, I had considered it previously, but since I have made this as question mark, this is invalid. Whenever I change make a change in specific, that means that has become invalid. Whenever something becomes invalid by making a change in specific, at that time reflect that change in general. Just that whenever you make a change in this one, just see if the same attribute what I made change is that in general or not, just delete it. Two steps. Whatever change you make in this one, just see if it was there in G3, delete it. That's all. The remaining one is your final answer. S4 and G4 are what? Final hypothesis. Okay, so that's all about the candidate elimination algorithm. I hope so you got the algorithm. Fine. Now small topic is there, not that important, just I'll finish it off in 1 or 2 minutes. Inductive bias means what? See, I'll be giving a basic example. If you want to build a house, okay, there are two things: unbiased, biased. Okay, so by this example you can easily understand. If you want to build a house, but you don't have enough money to hire a civil engineer, what you have the option left is either you have to arrange for money, negotiate with the civil engineer and hire him for buying the building the house, or you can learn from YouTube how to build a house from scratch and then make. This is highly impossible, right? So these two options are available in reality, right? So this is what is called unbiased. You'll be learning from scratch how to build a house, and then you'll be building. That will cost a lot of time and effort and money also, and useless house will be there. If one storm comes, it will be flying away, right? But if you hire a civil engineer, it will cost a lot of money, but the house will be better. That is what is called biased. Same way, in whenever we are finding some answer to the solution, at that time we will consider all the possible values, and then we'll be selecting some useful values, or you'll be just seeing what is useful, and then you'll be selecting that. But doing this will cost some extra money. That's what it is present here. In inductive bias, you'll be doing a combination of both. You'll not be going for most specific, also you'll not be going with totally considering all the values. Okay, you'll be moving somewhere in between, like in how data mining we had used that one, right? Materialization, like for example, choosing the most specific values. Consider the exam only. In exam you will be just studying the super important questions, right? Instead of studying all the syllabus, instead of studying just a few important questions, in between them what is there is super important questions, a few from this topics, also a few important questions also. That is what is called super important questions, right? So the inductive bias also is same. Whenever you are finding an hypothesis, at that time you will be considering the best one, not the most best also, not the worst also, but somewhat best. Okay, so that's what it is. And why we are doing this is because will the CE, okay, CE means candidate elimination, this algorithm gives us correct hypothesis always. Does it give? The answer is no. What training example should the learner request next? If you have got a correct hypothesis, what is the next I should consider to get more better hypothesis? Okay, for that we'll be using the inductive learning. Inductive learning means from the examples we will derive rules. Okay, there are some examples given, by that we'll be deriving that this rule is there. For example, the same thing you can consider: I like mango, I like apple, I like orange. Mango and I don't like apples. I like mango, I don't like apple, I like orange. By that, what conclusion I can form is orange color fruits I like, and red color fruit I don't like. That is what is called inductive learning. From the example, we are deriving rule that orange color fruit I like. Deductive means you have this rule: by orange color fruits I like, and by existing rules are applied to our examples. If orange color fruit I like, what is the fruits I like from this one? It will be applied to this one and see if it is yes or no. If it will apply to this one, you will see yes or no. If it will apply to this and see it is yes or no. Okay, so that's what it is. In bias hypothesis, it does not consider all type of training examples. Means it will not go to YouTube and see how to build a house and learn all the things from scratch. It will just hire a builder. Okay, it will not consider all the training example. For example, if it is sunny, warm, normal, strong, cool, then change, then only it will be yes. That's not means that's what it is doing. If it is sunny also, warm also, normal also, cold also, cool also, change also, if any one of these change, for example this changes, at that time what will happen? This will become no, even though five factors are there. Okay, and this was just an option. John actually doesn't care about this one. He actually cares about sunny and warm. These are all the normal options. But still, I got no. That's the wrong answer, right? Because he is mostly concerned with this one only, and this was just normal options. If it is there or not doesn't matter. So at that time, I got as no, right? That's the wrong answer. That is too much biased. In the unbiased, what will happen? We'll be considering all the possible combinations. For example, if it is sunny, warm, and something else, here if it is instead of strong, what will be there? Then means just one change of value, that also yes, another change of value, that also yes. We'll consider all the possible values from scratch and do that. Will give us correct answer, but it will cost a lot of target concept 2 power 96. Okay, it is very huge value. That much target concept we have to check, but we'll get the correct answer at the end after 100 years. What is the use of it? So we'll be combining these both and writing inductive bias. In that, it will just generalize beyond the observed training examples to infer new examples. For that, we'll be using x. Y is inductively inferred from y. Y is inductively inferred from x. So if you like this video, hit the like button and don't forget to subscribe to my channel. Your support helps me make more videos like this. And thank you so much for watching. I'll see you in the next one.